Hi, my name is Sohamanand. I'm from grade 3 and my age is 9. Today I'll be telling you about hurricanes and tropical cyclones. It was also dedicated for Beira health care for Cyclone Idai, which hit Mozambique last month. Where are hurricanes and tropical cyclones? Well, here's the map. This is the Earth. In the middle, we find the tropical zone, which is with the equator, but it's between the Tropic of Cancer and Capricorn. Here are the oceanic regions. Each region has a different name for a hurricane. So on this side, the Atlantic has hurricanes itself, cyclones in the Indian Ocean, willy-willies in the South Pacific, and North Pacific typhoons. Tropical cyclones originate in tropical areas of ocean, for example, Tropic of Cancer and Capricorn. Tropical cyclones have different names for different regions. So in the Indian Ocean, we know as cyclones, Pacific, typhoon and willy-willies, and Atlantic, hurricanes itself. You must be knowing this, that tropical regions receive maximum solar radiation per unit area. That is because of the incoming solar radiation is direct and vertical in the equator. But during the polar regions, it is going slant, not direct. So vertical rays of sunlight are more effective by producing more heat and light than slant rays. That is why tropical regions are warm and suitable for vertical rays. Now that you have understood that part, let's talk about wind movement. So wind movement is determined over high pressure and low pressure systems. It is the differences of atmospheric pressure that creates pressure gradient and makes the wind move. And keep in mind that wind always blows from areas of high pressure to low pressure areas. But what causes low pressure and high pressure? So low pressure occurs when the air is warmer, either in the warm land or surface of the ocean. That is, low pressure occurs on places that are warm. Do you know how? If not, then I can tell you. It is because of incoming heat from the sun. That is why tropical places are suitable for low pressure. Similarly, high pressure is when air is cool, either in cool land or ocean surface. That is why the polar regions, example around North and South Pole, there is a high pressure zone. Keep in mind that the wind blows from high pressure to low pressure areas. Now here is a type of force which I discovered, or everyone has known about it. Due to anti-clockwise rotation of the Earth around its axis, a type of force is generated which acts perpendicular to the direction of motion and to the axis of rotation. Hence, when the Earth is spinning from its axis west to east, and we know it's a sphere, and much wider in the middle, the result is that the speed of the surface at the equator is faster than the speed of the poles. So anything that comes from the poles straight to the equator gets deflected from the right in the northern hemisphere and south and left in the southern hemisphere, which is known to be our force we're talking about. That is Coriolis force. It causes fluids like air and water to curve from the Earth's surface. Now I made a drawing of the Earth, and if you can't see the pen mark, this is the equator. Here's the high pressure zone, and this is the other part of the high pressure zone. When it gets deflected, it will be a low pressure zone, and you might think it will go left. But no, to clear your confusion, you have to rotate the picture, and then you will actually see your own visual model, making it go right rather than left. Make sure you don't get confused again. Now that you have understood why air and water move to the left and right due to Coriolis force, just remember this point, that because of this reason, there are all certain pressure belts all over the Earth's surface. So you must be familiar with this picture, which shows global wind circulation pattern. You can see at different latitudes there are different pressure belts. Their existence is simply due to the movement of air to the left and the right. That is because of Coriolis force. Now let's talk about this. Formation of a hurricane. If you can see in the middle, you will find an area of low pressure, which attracts the cool air from high pressure area to low pressure area. That means the outer area of a cyclone consists of cool air coming from high pressure area, which surrounds the central low pressure area, which is widely known as the eye of the storm. The low pressure region is a warm region where the air is warm, which starts to expand and rises. Then the cool air from the high pressure zone rushes to fill in the low pressure zone void left by the rising warm air. Then this air warms itself and then becomes moist as well. After coming into contact with ocean region, it allows it to rise. Then more cool air keeps coming to fill the void. The warm and moist air cools as it rises higher than the atmosphere because temperature drops in increasing altitude. Also, clouds form there. While it continues, you will see an eye-like figure, and that will be known as the eye of the storm. Now comes the Coriolis effect. In the northern hemisphere, the cool air rushing to the center of the storm is deflected slightly to the right. But keep in mind that the cool air keeps getting attracted towards the center because where the warm or low pressure zone is moving towards the center, cool air keeps getting deflected, causing a spin in counterclockwise direction. While in the southern hemisphere, it goes left. While it's doing the opposite way, it starts to go clockwise. So hurricanes are very intense, and in the beginning we read that it occurs over the ocean surface and is a coastal region because there's a continuous supply of moisture from sea. But somehow when it reaches land, its moisture supply gets cut off, causing it to dissipate. When it crosses the coast, the landmass starts. So it will be known as the landfall of the cyclone, because the power of the storm will decrease by moisture supply cut off. I made this picture zoom in very big so that when you see it in the land, you will see it's starting to turn gray then white. That means it's starting to dissipate, firstly. Now let's do some math. So let's try length of hurricanes. The diameter for one hurricane is equal to 150 to 200 kilometers. However, the diameter of the storms in Bay of Bengal, Arabian Sea, and the Indian Ocean is till 600 to 1200 kilometers. Very big. They move slowly, like 300 to 500 kilometers per day. Woo. Now that we have seen the top version of a hurricane, let's see it vertically. If you see, there's the eye and in the middle, but the sides are known to be the eye wall. But its height is equal to the troposphere's height, which is almost like 15,000 to 18,000 meters high. When warm air rises up to the atmosphere, after a certain height, it starts cooling. Because remember, temperature drops in increasing altitude. As the air gets cooled, it starts to get dense and moves down to the ground. That is called subsiding warm air, and intensifies the storm by increasing the diameter. As the diameter increases, the spiral rain bands expand, pushing the rain clouds into the outer region, making the hurricane bigger. Tropical cyclones occur at the time of maximum solar radiation during the summer and autumn season. That is around July to October time in the northern hemisphere and December to March time in the southern hemisphere. These are known to be solstices and equinoxes of the hurricanes. Now it's time for trivia time. Did you know hurricanes can also be known as giant engines? Because imagine, that hurricane is a car. They use warm and moist air as a fuel. But the length of hurricanes which are used in the top version, it's more than 300 miles big. The eye wall, which is the middle of the hurricane, can be as long as 5 to 30 miles. That's really huge. And did you know the rain bands, which can give a pinwheel-like appearance, they can range from 50 to 300 miles. Woo! That is super big. And plus, hurricanes are divided into 5 categories. Category 1 and 2 are less dangerous, but for category 3, 4, and 5, they are very strong and powerful. That makes the storm stop dissipating easily, because category 1 and 2 can dissipate easily. But did you know a hurricane's energy can be equivalent to 10 atomic bombs per second? That is because the hurricane has much stronger force. Thanks for learning. Hope you enjoyed it. I hope you have heard about hurricanes. And this is all you've heard about it. Bye.